Let us look at proposition number 12 of book 9 of Euclid's Elements. The proposition says, if as many numbers as we please, beginning from a unit, are in continuous proportion, then by whatever prime number the last is measured, then next to the unit is also measured by the same. So what the proposition is saying is, we have a continued proportion starting from a unit, and if any prime number measures D, then it also measures A. Okay, let's see how we can prove this. So we are given unit A, B, C, D in continued proportion. E measures D. We are told that it is measured. So let E measure D, where E is any prime number. Okay. So what we have to prove is E also measures A. So we are going to use proof by contradiction. So let's assume that E does not measure A and see whether we can arrive at a contradiction. So if E does not measure A, that means A and E are relatively prime. Let E measure D. Let E measure D according to F. What this basically means is that D is equal to E times F. A measures D according to the units in C. Remember one of the previous propositions? We saw that a lesser number will measure a larger number in the continued proportion based on some number in between. So which is what we are saying. A measures D according to the units in C, which means D is equal to A times C. So this product is equal to D. This product is equal to D, which means the products are equal. So A times C is equal to E times F. In proportionality terms, it means A is to E as F is to C. If you look at A is to E, they are relatively prime. A and E are relatively prime. So which means they are the least numbers in that ratio. And the least number in that ratio will measure numbers in the same ratio, same number of times. That means A will measure F, E will measure C the same number of times. So which means we can say E measures C since A and E are relatively prime. Let E measure C according to units in G, which means C is equal to E times G. But we also know C is equal to A times B. So the products are equal. A times B is equal to E times G. In proportionality terms, it is A is to E is equal to G is to P. And again, same reasoning. A is to E. A and E are relatively prime. They are the least numbers in that ratio, which measure numbers in the same ratio, same number of times. So that means A measures G, E measures B, same number of times. So we can say E measures B since A and E are relatively prime. Okay. So let E measure B according to H. So which means B is equal to E times H. And we know also that B is equal to A times A. Remember, this is in continued proportion. So B is equal to A times A. So that means the products are equal. E times H is equal to A times A. In proportionality terms, we can say, let me just move this. Okay, in proportionality terms, this is E is to A as A is to H. Again, E and A are relatively prime. That means they are the least numbers in that ratio, and they measure numbers in the same ratio, same number of times. That means E measures A. But have we not reached a contradiction? Because we started with the assumption that E does not measure A, and we are reaching a conclusion that E measures A. So, which means there is a contradiction. What does that mean? It measures, it means that our assumption is wrong. So, E does measure A. A and E are relatively composite because they are not relatively prime. Since they are relatively composite, that means some number is going to measure these two numbers. But we know E is a prime number, and prime number is not measured by any other number except by itself. So that means no other number can measure E, which means we have to, that number is going to be one of these. So that means E measures A. Anyhow, A can't measure E since E is a prime number. So which means E measures A. Okay, so that was proposition number 12 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.